All right, lesson 3 for chapter 7, multiplying and dividing polynomials. So in the first lesson, we looked at multiplying monomials together, monomial by monomial. In the second lesson, we looked at dividing monomials by monomials. Now we're going to start incorporating larger polynomials. So we're going to look at a monomial times a polynomial to start. So just as a review, again, from lesson 2, I'm going to have you do these 3 questions on your own. I'll put the solutions up. I would like to see you doing your own work, though, and then we can check those together tomorrow. Please show me your work, not just your solution, because I'm going to give you the answers, so you got to do part of it. There are the solutions for the 3. I will check your work tomorrow. Okay. So talking about multiplying monomials and polynomials, so a monomial and a binomial in this case, the first thing we're going to do is we're going to start by modeling them out. So again, we're going to use the area method. Okay, the area model method. And so what that means is we've got the base and we've got the height to find the area of a rectangle. So one length is going to be the base length, one length is going to be the height. Doesn't really matter which one is which. So if we say a base of 3x, so 1, 2, 3x, and you can sketch it or you can build it, whatever you like more. And then the other length has to be 2x plus 4, 1. So 1, 2, 3, 4. Okay, so now we're going to multiply each piece and see what kind of tile fits it. So we have x times x, which makes x squared, x squared, x squared, and these are all positive. Again, we're making x squared, x squared. Okay, down here we have 1 times x, so that makes an x tile. X tile, X tile, 1 times X, X tile, X tile, X tile. Okay, so now when we look at the area, we're going to come add our like terms. So we have 1, 2, 3, 4, 5, 6 X squareds. And we are going to add the X's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Please notice that the side lengths that we used at the start to help figure out what area we put in, we do not add those into our total area. Okay, those are just there kind of as an outline. It'd be the same if I said, this is my rectangle, it has a length of 2 and width of 7. Find the area. You're not going to go 14, right? 2 times 7 plus 2 plus 7. They're just there as markers. In this case now, we have some variables and constants. Okay, so this is the area, 6x squared plus 12x. Looking at the second one, we're going to do a similar kind of model, base times height. So 4x is the base and 2x plus 3 is the height, or vice versa. So 4x, 1, 2, 3, 4, and then 2x and 1, 2, 3. So filling in the shapes, x times x gives us x squared. So 2, 4, 6, 8 x squareds. Okay, and then filling in x times 1 is x, x, x. So we have 12 x's. So 8x squared plus 12x, that's the area when we multiply these two. Okay. So with the tile method, same kind of thing, but we can build them with tiles and see what we get. Okay, so you should have something similar to this built. Notice that the 5 ones are negative. So sometimes when you have negative integers in your binomial or in your monomial, it's easier to use tiles to help show the different colors. So again, when we're filling in, we've got positive times positive, so that gives us positive x squared. So these are still all the same. I guess I could be dragging them. But. Okay, and now we have positive x times negative 1. So these are making negative x tiles. Oops. By the magic of television, oops, there we go. Drag, there we go. Beauty, magic. So that means our total area is 6x squared that are positive, and then we have 10 x's that are negative. Okay, so I'm going to ask you to try that one on your own. You can either build it with tiles or sketch it and then fill in the area to find out the area. Now, of course, there's always a second way, and so we're going to multiply, and it says multiply each term in the polynomial by the monomial. So each term needs to get multiplied. So this process is called the distributive property. We are distributing the multiplier, or distributing the coefficient across the binomial. This can be a little bit tricky at first, so if it doesn't make a ton of sense, don't get too worked up about it, but please make sure you come in for tutorial. So what's going to happen is we need to go 4x times 5x, and we need to go 4x times negative 3, because there's two terms. So I'm just going to split this up. So we need to go 4x times 5x, and we need to go 4x times negative 3. Okay? So then, again, we're thinking of it now just like binomial times binomial, right? Numbers with numbers, letters with letters. So 4 times 5 times x times x. So we get 20x squared. Okay, if we look over to the second one, numbers with numbers, letters with letters. So 4 times negative 3 times x. So then we get negative 12x. So together, 20x squared minus 12x. Okay? So sometimes when we end up multiplying like this, we create what's called expanded form. And so what we started with is called simplified form. Or you might hear it as factored form. We're not going to worry about these names too much this year, but definitely as you move into grade 10, you will see these names used a lot more. So it doesn't hurt to start getting used to them now. Okay, I'm going to show you this again, but I'm going to cut out a little bit of the steps because that's a lot of work to write down, and I hope some of you are starting to see a pattern that can kind of speed this up a little bit for you. So we have 7x that we need to times by negative 3x. So I'm thinking 7 times negative 3 gives me negative 21. X times x, x squared. Okay, so you're doing a lot more of this as mental math. If you still need to write it down, I encourage you to write it down. If you're ready to start not writing it down, then start not writing it down. 7 times positive 2x, or pardon me, 7x times positive 2 gives us positive 14x. So that's it, all together. We have x squared and x. They're not like terms. We can't combine them. That's it. We've turned it into expanded form. Okay, looking at the next one. I always like to reorder it so that the binomial is in front. That's just me being fussy. I can show you what it looks like without the binomial in front, and you can decide for yourself if you want to leave the binomial in front or put the monomial in front. So we need to go 5x times 4x, and we need to go 4 times 4x. So again, numbers with numbers, variables with variables, 20x squared plus 16x. X squared on x, same variable but different exponents, so not like terms, so that's as much as we can do. (8x) times negative 2x, negative 16x squared. 8x times negative 3, negative 24x. Okay, I hope that you're starting to get the hang of it. I'm going to ask that you try these next ones on your own. I am going to show you F because G and H have a couple more terms on them. So now it's a monomial times a trinomial or times a polynomial. So that can be a kind of tricky. So I'll show you F, and then the other three you're going to do by yourself. So when you have more terms, it's just like it was with a binomial, except now the monomial has to get multiplied a few more times. So we're going to go 4x times 8x, which gives us 32x squared. And then 4x times 4y gives us 16xy. And then 4x times the third term, 4x times negative 3 is negative 12x. So now we've made another trinomial. None of those terms have the same variable to the same exponent, so we can't combine any like terms. And so that's it. So you're going to try those three for me, and we're going to check them together tomorrow. Please show your work, not just your answer. I want to be able to see where your numbers came from.